It's going to be a quick demo of Mosaic, which is a set of tools written to implement music functions in a UNIX style. That is connecting operations on a text stream with pipes to provide different functions. So I've got the code here, and it's all written in ANSI C99 and only uses the standard library, so it's really small. You can see there's not many lines of code, and it compiles really fast as well. So if I do a quick demo now, you'll see the program structure, like when they're connected together, is broken down into basically modes and tonality and melodies and harmonies as well, is mainly what it operates with. So a good starting point is this program MD, which can take a set of notes as a command line argument, so you can do A natural or B natural or C natural, or anything, or sharps and flats. But if we do C natural and F sharp, just arbitrary, and then we give it this extra hyphen argument here, and that specifies to operate on the set of all modes. It's going to filter out all of the ones that do not contain all of these notes. So we can see here, these are all of the modes of the major scale, that is, that contain a C natural and an F sharp. If we didn't give it this argument here, it would expect extra input from standard in. So if we give it just, the first two, like, and then type it in here, we can see it only operates on that field there. If we add in something that's not there, we can see it's not going to be included. So this got filtered out because it doesn't contain both of these notes. So if we use this as a starting point for our pipeline, though, with this hyphen argument, so it just works on the set of all modes of the major scale, we can start to see how UNIX pipes and filters on text streams can be used here. So if we pipe it into this program int, which is for intervals, this one takes as command line argument a set of intervals. So if you want all the ones only that have natural seconds, natural fourths and natural fifths, so the most conventional sounding ones, then you give it like that. And then you can see we've filtered out like Locrian and Phrygian here because they don't satisfy these. If we only want the ones with flat thirds as well, we can say that, and then we've only got the minor ones, Dorian and so on, and not Ionian and mixed Lydian. But if we just leave it at this for now, and just filter out any more unconventional sounding ones and go from there. So if we wanted to start building some chords from these, for example, what we could do is use this chord program, CRD, and it takes two command line arguments, the first of which is the degree of the scale. So if you want chord 5 of a scale or chord 1, then you can do that. So if we just want tonic triad for each of these, then we can see what that is. Or if we want the dominant triad, then we can see that. But we can also do, and it's the same for all the other degrees of the scale, the diatonic triad, that is. Then we can also do extensions as the second command line argument. So let's say we want diatonic 7th as well, diatonic 9th, and so on. If we just leave it as the tonic triad for now, and we'll use that as a base to build a melody with, so we can pipe these chords, in this case these tonic triads for each mode, into a melody generator. And what this does is produces a melody of a specified length which emphasizes the notes of these chords by putting them on strong beats. So it's just a set crotchet melody, and it will put these notes on the strong beats and fill in the gaps in a musical way. So it takes as the first argument the length of the melody in crotchet beats, and then a seed, which can be anything. Basically it's used injects some randomness to generate the movement and steps of the line, so whether it wants to go up and down and so on. Just use one arbitrary here. This could have just been internally random, use the time as a seed or something, but this way then you can get like consistent results if you want to alter anything. See, just to interject here, we can see if we could put filtering before this, even though we've done it, and that's why this UNIX style can be quite useful. But if we just carry on, so now we've got our 7-note melodies here. So it's the same sort of steps and movement, but applied in these different keys. So if we wanted to, let's say, harmonize this, we can pipe this into a harmonizer. This doesn't take any arguments. Right now it just does like 3-voice. I wouldn't call it like, it's not Bach style, but it's conventional harmony with like a chord change every beat, basically. So if we do that here, we can see this is like your soprano line, this is your middle line, and this is your bass line here. And we have that for each of these modes here. So if we want to actually maybe use this in a different program or hear it, then we have a program that can convert to Music XML, which is a format used by score writers and some other programs. So all we have to do is pipe it in there, and it will convert this into the Music XML representation of, like, it'll sequence these one after the other in Music XML. So that's not much use just looking at it, but the idea is to output it to a file here and store it. So if we go to a program here, MuseScore, just as an example, we can open up this as an example and see, so these are the ideas sequentially. So we've got the C# Ionia idea here first, then the D natural Mixolydian and so on. So if we want to do playback, that just works straight away. And you can hear the different character of these different modes. But yeah, you could retroactively apply different filters here. Like for example, if we wanted the minor ones here, we could quite easily do that, and just, or if we wanted melodies built over chord 5 instead, we could do that as well. We could extend the melodies and use a different seed if we prefer. But yeah, so that's why the UNIX way, like, of this text streams could be quite useful, just to quickly get like some experiments down, or see some different results. So hopefully this gives a bit of an insight into how Mosaic could be used. I'll put a link to the code in the description. Thanks for watching.